Problem 5. How many distinguishable arrangements are there of one brown tile, one purple tile, two green tiles, and three yellow tiles in a row from left to right? So let's first, if people, for those who don't really understand what's going on here, let's just give ourselves an example. We have one brown tile, we have one purple tile, we have two green tiles, so two green, and we have three yellow, but yellow is hard to see, so I'll just say three yellow right here, and left to right. So we're trying to find how many distinguishable arrangements are there. Now, obviously, let's consider, for example, the yellows, right? And I'll call this yellow 1, yellow 2, yellow 3. Let's say I changed it into yellow 2, yellow 1, yellow 3, and all the rest remain the same. If I were to do this, let me ask you, would this combination be distinguishable from this combination? Well, the answer is no, right? Because yellow 1 is equal to yellow 2 is equal to yellow 3. They're all the same color, so there's no way you distinguish them. You can distinguish them based on combinations of the specific yellows in the order that they occupy. So what I mean by this is, let's give ourselves another example. Let's say I have green here, right? Let's say I put a brown here. Let's say I put purple here. Or no, let's say I put a purple right here, right? So then I'll put the yellows, one here, I'll put a yellow right here, I'll put a yellow right here. If I were, for example, to swap yellow 2 with yellow 3, would you be able to tell them apart from the original combination? Well, the answer is no, because they're the same yellow. So what can we derive here? We can say that, first of all, there are a total of 1 plus 2 plus 1 plus 3 ways to order them, right? Which is that they can all occupy, for example, the first one has 7 positions they can occupy. But then after I take one position, such as this one, then the remaining would have 6 ways to choose. So it's 1 plus 2 plus 1 plus 3 combination factorial, because that's the amount of positions that are available for them to occupy. Now we divide this by how many? We divide this by 1 factorial, 2 factorial, and 3 factorial. The reason for this is because of the reason that I just outlined for you. I can swap 1, 2, 3 with 1, 2, 3, 3, 2, 1, 2, 1, 3, 3, 1, 2. Doesn't matter. They will still be the same combination that's indistinguishable. Therefore, we divide out those cases by 3 factorial, which represents the number of ways I can rearrange yellow 1, yellow 2, yellow 3. And the 2 factorial stands for the ways I can recombine 2, and 1 stands for the 1 for the brown, and the other one stands for the 1 for the purple. So we divide this out and get our answer. That's 7 factorial over 2 factorial times 3 factorial, which becomes 7 times 6 times 5 times 4 divided by 2. This becomes 2. 2 times 5 is 10. 6 times 4 is 42. 42 times 10 is 420. Therefore, your final answer will be answer choice B.